Welcome to this tutorial. Kindly subscribe so that every time we post a new video you'll be the first one to get notified. So today we are looking at solving separable ordinary differential. We said the DE's first order differential equations have been grouped into various categories from my previous video. So if you have not checked that, kindly look at it up there. And then we proceed with this. So today we want to see how we solve separable ordinary differential equations. We solve separable ordinary differential equations. So this is how we do. So the first order DE of this form, remember we talked about that, is the first derivative, and it can be arranged in this form. It can be given in this form: m2 bracket xy dx plus n xy dy. So it can be in those two forms. Then as said to be, this form of ODE is said to be separable in terms if terms in x and those in y, terms of x and those in y can be separated. So separable, separated. So if you can separate the terms of x and y, then you say that kind of ODE is separable. So the DE can be rewritten in the form of the solution that can be obtained by integration. So you can see that you can now rewrite this form into this particular form here. So we have separated now. So when you separate, then m is a function for x and n is a function for y, because now you have separated. So you can write in that form because you have separated the x and the y, terms of x and y. Then after this you can get the solution. By integrating. So you basically need to integrate both sides. Then you'll be able to get the particular solutions, and you'll have solved the separable ODE. So if any initial conditions are given, we can solve to get a particular solution. So of course you solve, you get this kind of general solution. Okay, so let's look at an example. So we are given this initial value problem, and the initial value problem means that we have a condition here of only one value of x. And you can see from here x is equal to 0. That's one value we have, and y is -2. So now we have this kind of equation here. We just need to see whether it can be separable. So if it's separable, then you can solve it. And if it's separable, if values of x, terms of x and y can be separated, then obvious this will be a separable ordinary differential equation. So after that, we will be required to get the interval in which the solution is valid. So let's go deep and see how we work on this. So we rearrange. So we put values of y in the same sides, left hand side, and the values terms of x in the right hand side. So what we need to do now next from this, after rearranging this, we need to get the integrals, both sides. So we integrate both sides, and when you integrate both sides, on the side of left hand side, you'll find that after integration, using the laws of integration, you'll get that. And on the left hand side, you'll get, after integrating, you'll get this. x cubed plus 2x squared plus 2x plus a constant of course. Next, we use the initial values because this is IVP, is our initial value problem. So we use the initial values given to work for the constant. So they will help us to get the constant, the value of the constant. So substituting remember the values we had is 0 equal to -2. It means where we have y, we put -2, and where we have x, we put 0. So if you put all these through in this, you'll find that c is equal to 3. And therefore, substituting the equation here and rearranging, you'll find that we have this as the solution for this ODE. Is the solution for this ODE. So this solution here is a particular solution. It's a particular solution. Now the other part was we look at where the solution is valid. Where the solution is valid. So next, let us find the interval where the solution is valid. How do we go about this? So we will have to rewrite now the equation in the form of y as fx. So we are reading that on the left hand side we have y being equal to the values terms of x in the right hand side. So we'll have that and we'll have that. Now if you look at this kind of equation, basically if you want to solve them, you use a method we call completing square method. Use completing square method. So by completing square method, you'll find on the left hand side we need to add a c, which is 1 there, and adding this side you can see we have 4 here. So what to do in the left side you also do, so plus 1 so that the equation is constant. So if we factorize this side, we'll see we'll get this, and is equal to this. Getting square root both sides, we come up with that kind of equation. So that's our y is equal to 1 plus square root of all that. If you have a question on this bit about completing square method, kindly leave a comment there. I'll guide you on how we do completing square method, and I can even do a video over the same. So having gotten that, we want now to check the validity of our solution. So we determine either using the positive sign or negative sign which area our solution is valid. So if we take from the initial value conditions, our x being 0 and y being -1, the value of y is -1 plus, and we substitute x's with zeros, then we come up with this kind of answer here. So which is basically this answer. So you can see if we say -1 is equal to 1 plus 2, we are getting -1 being equal to 3, which is false. Okay, then the other one is -1 equal to 1 minus 2, so that's a case of negative. So we have -1 being equal to -1, which is true, and therefore that tells us that our solution is valid on the negative sign. So the negative sign is the one which gives us a valid solution for this ODE. So therefore we just omit the positive sign and we use the value in terms of the negative. So we pick negative here because that's what is giving us a valid solution for our case. So solving that, solving what is under square root, we find that x is equal to -2, which is the only real root. 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 So if you look at what we if we look at what we have here. Okay, so if you look at what we have under the square root here, we'll find that on the square root down here, if you solve this, what is under the square root, we are going to find that if we call that one px, function of x, we'll find that x cubed plus 2x squared plus 2x plus 4, if we factorize it using the methods of factorization, you'll find this is like x plus 2 then times x squared plus 2. So if you solve this, equating by 0 of course, x plus 2 being equal to 0, you'll find that x is equal to -2. That's real. Okay, then x squared plus 2 is equal to 0. We'll have x squared being equal to -2, and x is equal to this is basically what? This is basically I, which is imaginary, root 2 is imaginary, so that's not real. Our solution, we want it to be real, so that's the reason we are saying this x here, the x is equal to -2 is the only real root, the other one is the imaginary root, and that's the solution will be valid only for x being equal or greater to -2. So in case you have any question on this and I have tried to elaborate on this, you can also leave a comment. I'll be free to look at it and reach out to you. But for that to happen, remember you have to subscribe so that you'll be able to see a notification given. So bye for now, and thank you for your time.